You can look at the same landscape your whole life and think you know its story inside and out. But every once in a while, science peels back a layer and shows you a chapter you never knew existed. And today, we're diving into one of those stories. All right, if you're from the Texas Hill Country, you know this tree. You probably call it cedar, even though it's actually ash or redberry juniper. And for decades, it's been painted as the absolute villain of the region. It's the source of that miserable cedar fever, and it's seen as this thirsty invader that's changing the landscape for the worse. But what if that's not the whole story? For a long time, the case against juniper seemed pretty straightforward. I mean, from landowners to folks with allergies, almost everyone had a reason to want it gone. The rap sheet against these trees is long. First and foremost, there's the pollen, because of the legendary cedar fever that makes so many people miserable. Then there's what scientists call woody plant encroachment. Basically, these trees spread, and they can really crowd out native grasses and even those iconic Texas oaks. That, of course, leads to a loss of plant biodiversity. But maybe the biggest charge against them has always been that they're water hogs, that they suck up all the rain before it can ever reach our streams and aquifers. But it's that last point, the one about water, that a new scientific paper is putting under the microscope. It asks a pretty simple question, really. What happens to the land after a juniper dies? And the answer has been hiding in plain sight for more than 10 years. This research comes from a field called ecohydrology. It might sound complicated, but the idea is simple. It's the science of how water and our ecosystems are tied together. You really can't understand one without understanding the other, which makes it the perfect way to look at this whole juniper issue. So who's behind this work? The lead author is Austin R. Kelly. He's a PhD student at Texas A&M University and also runs his own environmental consulting company, ARK Ecological Consulting. The research is part of the Prairie Project, which is this awesome collaboration between universities all across the Great Plains, all focused on the science of healthy rangelands. And Austin teamed up with some absolute superstars in the ecohydrology field, Pedro Late, John Walker, and Brad Wilcox. These guys are already established heavy hitters. The design of the study was just brilliant. The team used the massive drought of 2011 as a natural experiment. They went out and found juniper trees that had died back then and were still standing. Then they compared the soil in 3 distinct spots, right underneath a living juniper, right underneath a tree that had been dead for a decade, and in the open grassland right next to them. And this is where the story gets really, really interesting. Because what they discovered about how water behaves under these dead trees completely flips our old assumptions upside down. So what really happens to the soil when a juniper tree dies and just stands there for 10 years? You might assume the ground just goes back to being like the open grassland, right? Well, it turns out that's not what happens at all. Not even close. Okay, take a look at this chart. We're looking at infiltration, which is just how fast water can soak into the ground. The results are just incredible. The soil under both the live junipers and the dead junipers soaked up water dramatically faster than the open grassland. And what's really key here is that statistically, there was no significant difference between the live and dead juniper soils. They were both in a class of their own. Let's put a number on that to really let it sink in. The soil under a juniper tree can absorb water up to 5 times faster than the compacted soil just a few feet away in the open. 5 times! And this shows that even a decade after the tree is dead, that incredible benefit is still there. To put that into a real-world picture, think about a massive Texas downpour. The soil under a live juniper could, in theory, handle about 30 inches of rain in 1 hour. 30 inches! Meanwhile, the open grassland would be overwhelmed after just 5 inches. All that extra water just runs off the surface, causing erosion instead of recharging our groundwater. It's a huge difference. So we know the effect is real, and we know it's incredibly long-lasting. But the question is, why? How does a dead tree leave behind such an amazing water-absorbing legacy for at least a decade? The answer, it turns out, is underground. In an open field, the soil gets baked and compacted over time. But underneath a juniper, that dense, fibrous root system creates this amazing network of channels deep in the soil. So when the tree dies, the roots slowly decay, but they leave behind that whole network of tunnels. The result is a soil that's less compacted and acts like a giant sponge just waiting to soak up rain. And the researchers say it perfectly in the paper. I'll quote it directly. These results suggest that even 10 years after tree death, the positive influences on soil physical properties persist or increase. So this isn't a temporary thing. This positive effect on the soil lasts and might even get better for at least a decade after the tree is gone. So this isn't just a cool science fact. This discovery has some pretty major implications for how we should think about managing land, especially here in Texas. It calls for a much more thoughtful approach. So what are the big takeaways here for landowners? First, the amazing soil benefits from a juniper don't just vanish when the tree dies. That spongy soil is a legacy you can work with. And this leads to a crucial point. How you remove junipers matters a lot. If you bulldoze them and tear up the soil, you could destroy this whole benefit. But if you use low disturbance methods like cutting them and leaving the root system in place to decay, you can preserve that incredible soil structure. It's a powerful new piece of the puzzle. Now, let's be very clear. This doesn't suddenly make junipers the good guys in every situation. They still cause serious allergies. They can still harm biodiversity by crowding out other plants. The juniper story is, and always has been, complicated. This research doesn't give us all the answers, but it gives us an absolutely essential new perspective on their role in our water cycle, a perspective we can no longer ignore. And that leaves us with a huge question to think about. Knowing that the ghost of a juniper leaves behind this incredible gift for the soil, how can we use this new understanding to transform the way we manage our landscapes? To find a better balance between ecology, agriculture, and our most precious resource, water. This is the kind of work that can have a real impact on the world around us. If you want to dive deeper into this or follow future research, you should definitely connect with the lead author, Austin R. Kelly. You can find him and his consulting firm at arkecological.com. All his contact info is right there for you. It's a great reminder that there are always new chapters to discover, right in our own backyards.